In this lesson, we're going to discuss the Simple Network Management Protocol. SNMP is an internet protocol for collecting and organizing information about managed devices on IP networks and for modifying that information to change the device's behavior. When we talk about managed devices, we're referring to any device that can communicate with an SNMP manager known as the Management Information Base, or MIB. Now, this includes things like routers and switches and firewalls and printers and servers and even your end-user client devices. SNMP can be used to send and receive data from these managed devices back to a centralized network management station. When you're configuring your SNMP architecture, you have to have a manager and then you have agents. Now, the SNMP manager could be any machine on your network that's running the SNMP protocol to collect and process information from the devices on your LAN or WAN. Normally, though, you're going to set this up on a server, especially in a large enterprise environment. Now, the agents are different network devices that are sending information about themselves over the network back to that manager. Usually, an agent is just running a background service to collect the data and send it back to the manager at regular intervals, or when they're requested to do so by that manager. Now, the SNMP manager is essentially a master node, and it's going to be able to send and receive these messages to those agents using 3 different message types. These are set, get, and trap messages. Now, the set and get messages are pretty straightforward. The set request is a manager to an agent request, and it's going to change the value of a variable or a list of variables. When this request is received by the agent, it's going to update its variables to the latest status and then provide a response to the manager with a list of all the new values for that variable. A get request is a manager to agent request to retrieve the value of a variable or a list of variables. Using a get request, one or more variable values can be requested from the agent by the manager. Now, a trap message is a little bit different though, because these are going to be sent asynchronously as notifications from the agent to the manager. In the case of trap messages, the agent is going to send the information without first being requested from the manager. This allows the agents to notify the management station of any significant events that are occurring in near real time. In general, traps are going to be used to provide events or alarm notifications to the manager from the agent. Since trap messages are unsolicited information being sent from the managed devices back to your network manager, you might be wondering what kind of information is contained within an SNMP trap message. Well, this can include lots of things. Things like uptime, configuration changes, unexpected downtime of a particular network link, or other essential information on your network that's used in the monitoring and detection of unforeseen events and network outages. Now, there are 2 different methods used to encode the data inside your SNMP trap messages. These can be sent as granular traps or verbose traps. With a granular trap, each SNMP trap message is sent with a unique object identifier, or OID. This number allows the SNMP manager to distinguish each message as a unique message being received. Now, an OID is a unique object identifier, which identifies a variable that can be read or set via SNMP. As these individual OIDs are received, they're going to be consolidated and stored inside a translation file known as the MIB, or Management Information Base. The MIB is used to describe the structure of the management data of a device subsystem using a hierarchical namespace containing the object identifier, that OID, as well as other information. Since the MIB contains all the details about the OID, this now allows the SNMP trap messages to send just the changes for a particular OID and not the entire list of data known about every variable or measure on a specific device or system. This saves bandwidth on the network for us because SNMP traps don't send redundant information over the network. Instead, they seek to conserve network resources for us. Now, if we're using verbose traps, the SNMP traps may be configured to contain all the information about a given alert or event as a payload. Since more data is being sent to the manager from the device, it's going to take up more resources on that server for it to be able to analyze the data contained within each trap. This takes more resources and it's going to use up more bandwidth as it goes over our network. Now, data in these SNMP traps are going to be sent and stored in a key value pair configuration. This is known as variable binding. For example, I might have a list of variable bindings for a particular router, things like site name, PR branch, criticality, high, severity, low, alarm description, high temperature, and other pertinent information for a given alarm or event, basically that's going to be reported through one of these trap messages. Now, when you're implementing SNMP in your network, you need to keep in mind that there are 3 different versions of SNMP, and they're not all created equal. SNMP version 1, version 2, and version 3 have different and varying levels of security. Now, as you can probably guess, SNMP version 3 is the newest and it was built as an improved version over version 1 and version 2, making it the most secure. When you're dealing with SNMP version 1 and version 2, These versions use a community string to give them access to the devices as their security mechanism. Now, these community strings act as a shared secret key, but in SNMP version 1 and version 2, it was sent and stored in plain text, making it really insecure. Now, these default community strings are either public read-only or private read-write, and the devices are considered a huge security risk when they're using these default community strings in SNMP v1 and v2 because they're vulnerable to attack. So in SNMP version 3, there was some added security to overcome this issue. To mitigate the vulnerability with the community strings, SNMP version 3 provides 3 security enhancements which added integrity, authentication, and confidentiality to the SNMP protocol. So how does SNMP solve all these problems? Well, for integrity, they started hashing the messages before they were being transmitted to make sure nobody could alter the data as it was being sent from the routers or switches to the management node. For authentication, they started validating the source of the messages. That way, you knew where they came from. For confidentiality, they added encryption and they started using DES, or the Data Encryption Standard, with a 56-bit encryption key to provide confidentiality and privacy. Now, if you know anything about encryption, you know that DES is considered a weak algorithm. And so, over time, it's been replaced by 3DES and now AES, the Advanced Encryption Standard, in newer devices that rely on SNMP v3. But you can only use those newer algorithms if you have a firmware on your device that supports those newer algorithms. If not, you're still going to have to rely on DES. Now, another benefit of SNMP version 3 is that it groups our SNMP components into different entities to increase security. Each group can then be given different authorizations and access privileges such as read, write, or read-write access. By allowing us to create groups of smaller and smaller sizes, we can better protect our networks and the SNMP traps that are being sent across them.